Kia ora, here's question 2A from the 2015 Level 3 Probability Distributions paper. So there's an achieved and a merit part of this one. It should be pretty quick and hopefully not too painful. Okay, it's about a car driver training company preparing its customers, which might be some of you, for the restricted license test. And it's written down information about customers who passed the test. This is the probability distribution of the random variable n. N is the number of attempts at the test. And that includes the attempt where they were successful at passing the test. Okay, so you can't have 0. And we're asked to calculate the mean number of attempts at the restricted test by customers of this company who passed. In other words, take the information in this table and work out the expected value or average value of that little probability distribution. Now, we know that we get the average by just doing a weighting over each of those columns. So it's the probability that, I haven't finished that thing yet, it's P of n equaling all the different values, 1, 2, 3 and 4, times what the different values of n are. And we're going to add that up from 1 to 4. So that works out to be this. Right, so it's pretty intuitive. What it's saying is that we've got 1% of people who take 4 goes to pass, 3% of people take 3 goes to pass, and so on. So that gives me an answer of, on the next slide I think, okay, so that works out to be 1.23. Now some of you might be thinking, well, you can't have 0.23 of a driving test. Don't round this number. What it's doing is it's giving, it's kind of a mathematical precise piece of information about the average of that distribution. So we're not trying to say it's roughly one person, it's 1.23. The reason we want to be precise is if we're using that in problems later on, we're going to chuck out a whole lot of information by rounding it to 1. Okay, so now on to the next part of the question, which is the merit part. So the cost of the restricted license test is $137 per attempt, and they charge a fixed price for customers to prepare them. So we can think that the cost is equal to, for a customer, is going to be equal to 137 times n, the number of goes that they take, plus, we'll call it k. K is the fixed cost. We're asked to figure out what is that fixed price. Well, we know that the expected value of the cost is equal to this, and we know how expectation algebra works, so that should actually be a capital N there. So this is the information that we're going to work with, but we get told the mean amount paid for the tests and the training, and that was $468.51. So here's what we've got: 468.51 is equal to 137, and we also know the expected number of time goes taken is 1.23 plus k. So we've got 468.51 is equal to 168.51 plus k. So you should know at this point that you've got it right, because k is a lovely round number, it's $300. Alright, so k is equal to $300. That's the fixed price charged by the company. Now, if you're watching this and you didn't like this bit here, remember this is done in the ESA workbook really nicely, and it's right near the start of the probability distribution section. Okay, that's all from now. I'll be back later on with the excellence question.